Hello everyone, welcome to Morningstar 启明星 Math Contacts training course. Today, I am going to introduce you a area problem related to triangles. Firstly, let's read the problem. Triangle ABC is right triangle with the angle ABC is the right angle here. Point P is in line AB. Point P here. Point R is in line BC. Point R in line BC. And point Q in line AC. PQRB is a rectangle. We already know the length of AP here is 3 and RC is 13 here. What is the area of rectangle PQRB, the shaded area? Okay, so the problem's description is straightforward. As we all know, to know the area of a rectangle, we just need to know the closing two sides length, such as the length of PB and BR, or PQ or QR. But when we reread the problem, we notice that the length information given to us is quite separated. We know the length of AP here and RC here. For sure, we know that we need to use them, the two values, to calculate the shaded area. But how? Okay, actually, I want to introduce you two solutions onto this problem. Firstly, I introduce the solution 1. We know the length of AP and we know the length of RC. The challenge we are facing is how to make them together. We try to make a parallel line with the line PQ through the point A. We normally use dot line for assistant lines. And we extend the line RQ to intersect. To intersect with the line we just made. And there's an intersection point. We name it as point D. We have a new rectangle, APQD. AP's length is equal to DQ. So we know the length here is also 3. And we do the similar thing onto this area. We make a parallel line through the point C with the line RQ and extend the shaded rectangle's side PQ to intersect with it. And we also name the intersect point as point E. Similar as this rectangle, we have a bigger one. And the assistant line we just made to make them intersect. Here, we name it as point F. So we already have a new rectangle, APF. ABCF. We transfer original triangles into rectangles. Okay, so what I would say, firstly I tell you the solution. I would say this new rectangles area, which we had known their size, length 3 and 13 here, is equal to this one. D, F, E, Q is equal to rectangle P, Q, R, B. This is the target conclusion we want to prove. This triangle's area is very straightforward. Is 39 because 3 times of 13, right? Easy peasy. Here it is for sure, but the question mark should be put here. Firstly, we know that triangle ABC equals to triangle AFC. C equals to triangle QEC. Okay, so we have 3 equations. Then we have because then this minus this and minus this is equal to this minus this minus this. Okay, this equation is for sure correct because regarding the original 3 equations, we had done the same actions in the left and right sides. But what is the left side and what is the right side? A triangle ABC. ABC removes APQ and removes QRC is what? It's just the rectangle. How about the right side? How about the right side? Say, this triangle AFC remove ADQ and remove QEC is what? Is this rectangle. FEQ. Okay, correct. So we approved this equation. And this equation is just what we are going to approve here, where we had put a question mark here, right? So we approve it, meaning this equation, this triangle's area equals to this triangle's area equals to 39. Okay? Got it? Okay, as I said, we have 2 solutions. We go back to the original figure. Ignore all the assistant lines we made. We can notice that we have 2, comparing the original triangle ABC, we have 2 smaller ones, which are triangle APQ and triangle QRC, right? Triangle APQ and triangle QRC. Means these two triangles has exactly the same shape, but different size. They keep the same ratio. This means the length AP onto its AP, this onto its corresponding side, and this triangle, which is it? It is QR. QR is equal to PQ. Okay, so when we reconsider the problem's given conditions, we notice that we have known the value of AP, right? So we replace AP with 3. Replace RC with 13. RC 13. Okay. We can find that when we crossingly multiply them, we get the equation PQ multiply with QR is equal to 3 times 13, 39. But what is it? PQ onto RQ. PQ is actually one side of the triangles we are working on to, PQ. And which one is QR? QR is its closing side. The area of rectangle PQRB. PQRB. This means PQRB triangle's area is 39. We got the same value as the first solution. Obviously, the second one is easier. Thank you.